In this lecture, we will solve some more example of conjugate, modulus, and argument of a complex number. If Z1, Z2, Z3 are three vertices of an isosceles triangle, right angle at Z2, right angle at Z2, prove that Z1 square plus 2Z2 square plus Z3 square equal to 2Z2 within bracket Z1 plus Z3. Answer. Let us denote the complex numbers Z1, Z2, Z3 by A, B, C respectively in the Argand plane that is this is my vertex B denoted by this is Z2 vertex B denoted by B, and this is Z1 denoted by A, and this is C denoted by Z3. Our angle ABC is 90 degree. Arc of Z2 minus Z1 by Z2 minus Z3 is equal to pi by 2 or minus pi by 2. That is angle between Z2 minus Z1 and Z2 minus Z3 is pi by 2. This angle is pi by 2. Okay? And since the triangle is an isosceles triangle, Z1, Z2, Z3 are the vertex of isosceles triangle. BA is equal to BC. Here, arc of this number is equal to 0. That means this number is purely imaginary. Z2 minus Z1 by Z2 minus Z3 is purely imaginary. If it is purely imaginary, then its real part of this complex number is 0. That is Z2 minus Z1 by Z2 minus Z3 plus within bracket Z2 minus Z1 Z2 minus Z3 is equal to 0. Using the property of conjugate here, this is Z2 minus Z1, Z2 minus Z3. Yes, using the property of conjugate, this is Z2 conjugate minus Z1 conjugate. This is Z2 conjugate minus Z3 conjugate. This is equal to 0. In the next step, I am bringing bringing second term. Bring this second term to right hand side. It will become minus z2 conjugate minus z1 conjugate by z2 conjugate minus z3 conjugate. Put this equation 1. Again, one can easily see that this is a isosceles triangle. So this side BA is equal to BC. So using this property, BA is equal to BC. What is BA? BA is my Z2 minus modulus of Z2 minus Z1. And this is Z2 minus Z3. Squaring both sides. We get Z2 minus Z1 by using the properties of modulus. Z2 minus Z1, Z2 minus Z1 whole conjugate. In the next step, it will be conjugate. This is Z2 minus Z3, and this is Z2 conjugate minus Z3 conjugate. Put this equation 2. Now multiplying 1 and 2, we get this is Z2 minus Z1, this is Z2 conjugate minus Z1. If I multiply with this one, Z2 minus Z1, Z1 minus Z2 conjugate, multiplying these two, then it will be Z2 minus Z1 whole square. Then this term again in the denominator, it is this term. So write the left hand side. Z2 minus Z1 whole square, Z2 minus Z1 conjugate, then Z2 minus Z3. Okay, this is in the left hand side. In the right hand side, it will be minus Z2 Z1 Z2 Z1 conjugate of Z2 Z1, then conjugate of Z2 minus Z3. Here this will be cancelled with the denominator of 1, and we have Z2 Z1 conjugate, then multiplied with Z2 Z3. Put your minus conjugate of Z1 Z2 Z1 conjugate multiplied with Z2 minus Z3. Z2 minus Z1 conjugate, Z2 minus Z1 conjugate, then Z2 conjugate minus Z3 conjugate. Cancel with Z2 conjugate with Z3 conjugate. We will left with Z2 minus Z3. Then multiply these two, cross multiplication. In the next step, it will be Z1 conjugate, Z2 minus Z1 minus Z2 conjugate minus Z1 conjugate. This will go to here, and it will be z2 minus z3 whole square. This will be z2 minus z3 whole square. This one will be z2 minus z1 whole square. z2 minus z1 whole square. Bring this to left hand side. It will be z2 conjugate minus z1 conjugate. z2 minus z1 whole square plus z2 minus z3 whole square. z2 conjugate minus z1 conjugate is equal to 0. This is equal to, take z2 minus z1 common. z2 conjugate minus z1 common. Within the bracket it is z2 minus z1 whole square plus z2 minus z3 whole square. This is 0. As z2 is not equal to z1, this implies conjugate of z2 is not equal to conjugate of z1. This implies conjugate of z2 minus conjugate of z1 is not equal to 0. Therefore, we have only one option. When product of these two terms is 0, this term is not 0, that means this term must be 0. And this z2 minus z1 whole square plus z2 minus z3 whole square is equal to 0. We have this z2 minus z1 whole square plus z2 minus z3 whole square is equal to 0. If I expand this, I will get z2 square minus 2z1 z2 plus z1 square plus z2 square minus 2z2 z3 plus z3 square is equal to 0. z1 square plus this is 1 z2 square, this is 1 z2 square, this is 2 z2 square, z3, this is z3, this is z3 square, this is minus 2 z1 z2, this is minus 2 z2 z3. Bring this to right hand side, this is z plus 2 z1 z2 plus 2 z2 z3. The next step, take 2 z2 common from the right hand side. This is 2 z2 within brackets z1 z3. Hence the region. This is 3. With that, I would like to conclude. Thank you. Remaining will be in the next lecture.